Hello everyone, we're gonna continue chapter 1, Tools of Algebra, by discussing the inequalities. In the last section we talked about equalities, but this time we're gonna deal with the different symbols such as greater than sign, less than sign, where greater than or equal to, or less than or equal to. So let's break down this section. So problem type 1 and 2, is pretty much the same except the problem type 2 deals with compound inequality, which I will explain in detail in a few minutes. And when you graph, it's gonna use a number line instead of a XY coordinate system. And then we'll deal with a word problem that deals with inequalities. And I'm going to break down each sentence and then translate the English language to mathematical inequalities and then solve for it. So let's talk about properties of inequalities. The property of equality and property of inequalities are pretty much the same except for the multiplication property and the division property. Anytime you multiply by a negative number on both sides of the inequalities, then you are supposed to switch the sign of the inequalities. So for example, you can see here that BC is greater than or equal to, but when you multiply by, say, C equals negative 3, then AC is greater than or equal to, right here. And also the same is true for the division property. So if C is like a negative 5, and you divide it on both sides of the inequalities, and you see the reverse there. Okay, and let me talk about compound inequality. Simply, they require more than one. Basically, they require two inequality symbols. So for example, if I say x is between 2 and 3, that will be a compound inequality. And also if I say x is x is less than negative 2, or x is greater than 2, let's make it equal sign as well, then this will be also inequalities because I use the two symbols of inequality. And if I have to graph this, this kind of notation you will see often will be a segment. Okay. Oh, another thing I need to mention is if you see no equal sign in the inequality, then do not fill this circle here. So on the next example here, I said x is less than or equal to negative 2. Okay, so you draw the number line, and this time I can fill that circle on negative 2, and this is an x-axis, and it says x is less than, right? So you do have to mention that it's, or this including negative 2, it's gonna shade to negative infinity. And if x is greater than or equal to, then I have to have a solid disk 2, and that's going to be greater, and that covers to the positive infinity. Now this AND statement, usually this is what we call AND statement. Like I said, you have one segment. In the OR statement, you have two rays extending to the extreme. Okay, it's time to solve some problem together. Okay, you said solve inequalities. So when I see this, I identify the x's, and as you can see, x is the only variable, so that means we have to place x on one side of the equation and the rest numbers to the right side of the equation. And the proper step will be first tackling the parentheses, and especially the inner parentheses. So I'm going to first use a distributive property to remove these parentheses you see here. So copy this down. So negative times 3x, you get negative 3x. Now here's something you have to be careful. Negative times negative 4 is positive 4. So make sure you write plus 4. And then let's use another distributive property. And it's going to be 6x plus 9. Okay, still we have to do some more work. But first I recognize that 5x minus 3 is like term. So I'm going to make it 2x plus 4. And on the right side, I'll just keep this for now. Okay, and I use a distributive property one more time. And it's going to be 4x plus 8 is less than 6x plus 9. Now, this is a like term. I mean, these are like terms, and then these are the like terms. I'm going to first divide by, I'm going to subtract 8 on both sides. So the numbers are on the right side. And I'm going to subtract by negative 6, just so that all the x's are gathered on the left side of the inequality. So 4x minus cx is simply negative 2x, and the 9 minus 8, I should have positive 1. So here is where I just talked about the multiplicative property. If I divide by negative 2 on both sides, then it's going to switch the direction of the inequality. So it will be x is greater than negative 1/2. And of course, I do have to draw the graph. I forgot the direction here, graph the inequality. I have x equals negative 1/2. That's like a negative 0.5. So if this is 0, and say that's negative 1, this circle I just drew will be negative 1/2. And then it says x is greater than, so it's going to cover all the region beyond it. So that's how you do number 6. So your answer to this should be box like that. And let's go to the next problem. This time we deal with the compound inequalities. As you can see that the inequalities are linked or joined by this end statement. Okay, first, don't be afraid of this. Just tackle one by one. So I'm gonna add 5 on both sides. So 3x is greater than or equal to negative 3. And this may trick you, but because I'm dividing by 3 on both, I do not have to switch the symbol here. Had I been dividing by negative 3, then yes, I would have to. So x is greater than or equal to negative 1, and we can keep that end. And over here, just add the 5 on both sides, and I have 3x is less than or equal to 6, and then divided by 3, so x is less than or equal to 2. Okay, I can simplify more by having this one. Okay, first of all, on both sides of the inequalities, I have the less than or equal to equal signs there, so keep them. And since I have x greater than negative 1, put them on the left side, and but it's less than 2. So here's one compound inequality that I can write. Remember, the compound inequality involves 2 inequality symbols, and then when I graph this, simply it's going to have a segment. So I have a terminal, negative 1. I'm going to have a solid disk because it includes the value negative 1 itself. And then it also includes x equals 2. And it's any points between these two numbers are valid. Let's go to the next one. Here's a word problem. Let's first have a habit of boxing the answer to get full credit. Okay, let's go to the word problem. A salesperson earns $300 per week plus 10% of her weekly sales. Find the sales necessary for the salesperson to earn at least $800 in a week. First thing you gotta do is just break down the sentence. Sometimes the whole paragraph may intimidate you, but by breaking to each sentence or phrase, you can manage with a biteable size. So a salesperson earns $350 per week. Okay, that's good enough. And if you see the next sentence, here's the good news. Okay, yeah, it has also 1 week here too. So number of weeks is not really gonna affect our problem. Well, let's see the 10% of her sales. So she obviously has commission. Each sale she makes, she's gonna make 10% out of it. Okay, so as long as you understand that, that's good. So those are the given. So if I have to translate that, I'm gonna have, say, E equals earning. Okay, clearly the 350 will be the base salary, and then let's say X equals number of sale, then 0.10, which represents the 10%, X is gonna be the commission she makes. And let's just say for now that E equals this amount. Okay, so whatever number of sales she makes, then she's gonna earn that much. But if you see the next slide, okay, find the sales necessary for the salesperson to earn at least 1 week. We talked about 1 week, but it says at least $800, and the goal is to find a sale. So let's go back. The goal, so this is a given, and goal is like number of sales. In other words, we are looking for that X. Okay, but they did specify that the earning is at least $800. Then we're gonna replace the E 800, and then it's at least, and at least means you gotta make at least. So in other words, the side of the inequalities that takes the variable has to be greater than or equal to 350 plus 0.10x. Now this is more proper equation that fits in the context here. So I can just, yeah, I can make like that on the top. Okay, I'm done actually, at least for the setting up. Once you are able to set the question up or the problem up and the equation up actually, and then know that you're looking for the x in inequality, then all you gotta do is simplify. So let's simplify by subtracting 350, and I get 450 is less than or equal to 0.10x. 0.10x. Okay. 0.1 is equivalent to 110. So if you multiply, or actually let me show you a full step. That multiply both sides by 10. 10 times 450, you're gonna get 4,500, and that's gonna be equal or less than x. Okay, now let's use the symmetric property so that the x is on the left side. Okay, so what does it mean? That she needs to make at least 4,500 sales to earn $800 at least in 1 week. So that's how you solve the problem, and we'll see you guys next time.